Continuing with the Computer Science AS Level 9618 curriculum, we're going to be taking a look at topic 8.1, database concepts, and this primarily focuses on normalization. So let's take a look at the learning targets, know what we're looking for today, show an understanding of the normalization process going into first normal form, then going to second normal form, and then third normal form, 1NF, 2NF, 3NF, and then explain why a given set of database tables are or are not in 3NF. So we'll be taking a look at a couple examples as well as walking through how to take a table, converting it into 1NF, 2NF, and then 3NF. So there's some vocab you're going to need to know when you're in topic 8, when you're doing databases. So let's go over some basic vocab because we're going to be using some of these today. So we have what's called a tuple. This is a single row in a table that contains a single record for each column. That is extremely important. I don't want to say primarily important, but extremely important when you're doing normalization. That will be made abundantly clear today. Attribute is the column headings of a table. We also have something called a primary key. Now, this is a unique value assigned to each row, and it appears only one time for that table. We also have something called a candidate key. It's a column or combination of columns that could qualify as a primary key. A secondary key, which is any key that could act as a primary key but is not selected. We also have something known as a foreign key. So defined in a second table that references a primary key in another table. And if you're feeling overwhelmed already, don't. We're going to go through all this. I'm going to break it down nice and easy so it's easy to understand. So if you're feeling overwhelmed already, please do not. And the last one is what we call referential integrity. And this is whenever a foreign key is used in another table, it references an existing primary key in the parent table. And the foreign key must reference a primary key. If you have no idea what any of that means, hopefully this video will help you out. So let's jump in. So let's talk about non-key attributes and primary keys, get a basic understanding before we go through the example. So here we see our primary key is student ID. How do I know that? Because it's underlined. Also notice for each attribute, which is a column heading, there are no spaces. That is why the underscore is put in there. That's extremely important to know. If you're having to do column headings on a test or on the Cambridge exam, you definitely don't want to have spaces. You want to put in that underscore. Now, name is tied to student ID. The name is dependent upon the student ID. The units, on the other hand, are dependent upon the course ID. The units have nothing to do with the student ID at all. So not everything here is dependent upon the primary key. That creates a problem. So partial dependency, we're going to be talking about that today too. That's something else we have to look for. This is unrelated to the first table. We're just looking at some non-key dependencies here. This is a partial dependency. So we have two primary keys, customer ID and order ID. Now, we don't call them two primary keys. When two or more primary keys exist in a table, we call them a composite key. A partial dependency is when a non-key attribute, such as name, depends on part of the composite key, but not all of it. Name depends upon customer ID, but it has nothing to do with order ID. First normal form. So there are 4 rules. So with the problems we looked at, by creating a normalized table, you can get rid of those problems. And the first one is first normal form, and there are 4 rules. It should only have single atomic value attributes or for the columns. We'll talk about what that means momentarily. Values stored in a column should be of the same domain. This means of the same data type. All the columns in a table should have unique names. Now, because it's unique, there can obviously be no repeating columns, but there could also be no similar columns. And the order in which data is stored does not matter. It does not have to come in a specific order. So let's take a look at our first table here. This is our first table. We have Adam, who's 15, taking biology and mathematics. Alex, who's 14, taking mathematics. Stuart, who's 17, who is taking mathematics. Now, there are 3 things we need to look at here. Is this in first normal form? Is it in 1NF? If not, state which rule or rules is violated by the following table. 2, give an example of a problem this table could present to the school and a specific student. That's an inferring question. And then number 3, convert it to first normal form if it's not already. Now, if you have a basic understanding or you want to try to convert this to first normal form, go ahead and pause the video and we'll give you a few seconds to do that. Okay, so let's go over it. So let's take a look at the first one. Is this table in first normal form? If not, state which rule or rules is or are violated by the following table. Well, it's not in first normal form. It violates the first rule, which states it should only have single value for each attribute or column. Now we can see in row 1 with Adam, the column subject contains 2 values, biology and mathematics, instead of 1. Give an example of a problem this table could present to the school and a specific student. Well, Adam is the specific problem it could have. If Adam was to drop mathematics, it's going to delete him entirely from the system because we'd have to delete this entire row. Well, now Adam is no longer enrolled in the school. He's been dropped from biology. He shows up to school. He has no idea what's going on because his teachers say, "You are no longer on my roll." Now, the third one was to convert it to first normal form if it's not already. So this is what the table would look like if it was in first normal form. So here we see biology and mathematics is no longer in the row. They have been separated. But now we have 2 atoms. So we can see another possible problem. How do we know that atom is the same atom? We don't. Is it possible that another atom of the same age gets added? Could a third atom get added? Or would it be the second atom getting added? Is this the same atom or is it not? It's impossible to tell from this table. So how do we differentiate between these atoms if one unenrolls from the school or a class? Is it possible that another student has the same name as someone else and majors in the same subject? There are schools that have hundreds, if not a couple thousand students. There are going to be students with the same name who are the same age and probably majoring in the same subject. We want to prevent that. Well, if we converted this to 1 and F, how's that even helpful? So what does first normal form do if we still have those problems? 1 and F creates data redundancy, but it doesn't create useless data. By making the table 1 and F, we can prevent deletion irregularity. For example, if Adam drops biology, we can just cross him out. He hasn't been kicked out of the system because he's still taking math. But that still doesn't answer our question about the atom being unique. So let's talk about second normal form, and this is where you go to make sure that each person is unique. So there are only 2 rules for second normal form. First one's easy. It's got to be in first normal form. If it's in first normal form, you're 50% of the way there. Now, there's no partial dependency on the composite key if there is one. This means every non-key is dependent upon the entire composite key, not just part of it. There are no partial dependencies, which we looked at earlier. Now, this is important to know. If the non-keys are dependent upon a single primary key, then it's already in second normal form. If it's not and a primary key is being used, the table must be split. Now, rule 2 in the note makes this go different ways. So let's practice. We're going to take a look at a couple examples here, and then we'll get back to our table and convert it to second normal form. So this one, is this table in second normal form? We need to make sure it's in first normal form and that it's in second normal form. Now we have a composite key here. So taking a look, we know it's not because there are partial dependencies. Second normal form, there are no partial dependencies. Unit is dependent upon the course ID, but not the student ID. Name is dependent upon the student ID, but not the course ID. So we have to separate these tables. So let's take a look at that. We need to, this is our original table. We need to keep this information. We can't just get rid of it. We need to do that. And here is how you would do that. You would create 3 separate tables. The first one is a student table. Now they have some, to get this in the second normal form, you would simply delete this extra linen from the student table. How do I know it's the same linen? Because he has the same student ID. I don't need it there twice. There's no reason. I can add any student to this table, give them a student ID, give them a name without affecting the courses and without affecting this table, which we converted to this table, which we'll get to in just a second. Course ID. I have units which are dependent upon the course ID. Each course ID appears only one time. I can add courses to this table without affecting the students. But I still need this information. If I just have these 2 tables, I have lost this information. I need to know what students are taking what courses. So by doing that, I reference the primary keys through the use of foreign keys. Take a look at this student course table. We have two primary keys, but we don't call them two primary keys. We call them a composite key. How do I know I have a composite key? Because student ID is underlined as well as course ID. Each row is going to be unique. Now, student ID in this student course table is a foreign key, and so is course ID. It is also a foreign key. That's because student ID is a foreign key of the primary key, student ID in the student table. Course ID is a foreign key because it is referencing the primary key, course ID, in the course table. Now, that can be a little difficult to understand that first because we have primary keys. Any key that references the primary key is a foreign key. So let's practice and get back to our table. So second normal form. So here's what we have. Let's create a primary key so each row is unique because we had atoms. So we're just going to tack on a row and we're going to call it ID number, and that's going to be our attribute name. Now, it could have been student number, it could have been ID. It's really up to you as long as it's going to be a unique value. I can't use student name, I can't use the age, I can't use the subject. Those aren't even up for debate because we're going to have repeating data there. That's not going to make it unique. By adding an ID number, it is now unique, and now I know that these atoms are the same atoms. Now, if you're wondering, how did I figure that out? I didn't. I'm just using that as an example. If we had the original table, there would be no way to know it was the same atom if we were presented with that. But now that we have a primary key and we have it set up, we can go ahead and know that it is the same atom. So we have a problem here. The primary key should be unique in each row. It is not. We're still in first normal form. We also have a violation of Rule 2. Each student is tied to a unique ID number. So the age is dependent upon the student, but the subject has nothing to do with the student. Your name does not have to be Adam to take bio, for example. We need to separate this data into separate tables. So here was our table. Here's the problem. Your name does not have to be Adam to take bio. So all we're going to do is chop off the subject. That's all we're going to do. And this would be our table in first normal form. This is what we started with, or excuse me, second normal form. This right here is what we started with. We chop off subject and we have a repeating. So now we can get rid of the repeating data. We chopped off subject, remember, and now this would be my final table for the students in second normal form. So now we have a table that has relatable data and only one primary key. Adam doesn't need to appear twice. We don't need two Adams who's the same person with the age. We don't need that. We just get rid of that extra one. We still have Adam in the system. We have Alex, we have Stuart. We haven't lost any information for our students. So we have started to get rid of data redundancy for the student table, and that's what second normal form does. Now, we need to do the subject table. Now, we don't need math 3 times. That is data redundancy. Well, I can tie each of these different subjects to a course number. The subject has nothing to do with the ID number, the student, or the age. So I put it into a separate table. I have the course number 1, which is biology, course number 2, which is math. Now, it doesn't have to be course number. It could be ID, it could be course ID number. You can call it whatever you want. But now we have a table that has relatable data with only one primary key, course number, with no row having the same primary key again. We have started to get rid of data redundancy for the course table, which is what second normal form does. So this would be our final tables in 2 and F. So the first one, we have course number and tied to the course. We have the ID number tied to the student, but we need to get back to that original table. And we do that through the use of foreign keys. And here I have a composite key, ID number and course number. Course number is referencing the primary key, course number in the course table. ID number is the foreign key referencing the primary key in the student table. we have our final tables here. Every table needs to relate to the other, and this is where the foreign keys come in. I cannot just chop these into two separate tables. I need another table that ties this information together. So in this table, we have two foreign keys, which also act as a composite key. I can't use ID number, just ID number in this table, because I have repeating values. I can't use course number in this table, because C2 appears twice. Student 3 is also taking course 2. There is no course 3. That is a typo on my part. If we wanted to add course 3, we could do that to the course table, not affect this table, and not affect the student table. So it's in second normal form. So second normal form, each table does what? So we have this table, and this table allows us to add or delete students without affecting anything else. If a student unenrolls, it's going to delete them from all the tables since there are foreign keys. It also contains a primary key that makes it uniquely identifiable. Now, this table right here allows us to adjust courses. So it makes it very easy. And then last but not least, we have this table. And this table shows what each student is taking. The ID number is linked to the ID number in the previous table that we saw. This table right here has a composite key, which makes each row unique. If I was writing this out on an exam, I would call this student schedule. That's the name of the table. ID number, which is a foreign key. Course number, which is also a foreign key. Remember, course number, this is a foreign key because it references a primary key in the course table. ID number is a foreign key because it references the primary key ID number in the student table. All right, third normal form, getting to the end here. So getting very close to the end. And there are only two rules for third normal form. The first one's easy. The table must be in 2NF. If you get it in 2NF, you're 50% of the way there. Now, just to be clear, sometimes when you're in 2NF, you're also already in 3NF. Looking at our last table, this is also automatically in 3NF as well. How do you know if you need to go to 3NF? There can be no transitive dependencies. This means one non-key column is related to the primary key only through another non-key column. What in the world does that mean? Well, Cambridge states it like this. All non-primary keys are related only to the primary key. So let's take a look at this example and let's talk about both. So the first one is there's no transitive dependencies. Department name is related to the primary key, employee ID, through the department ID. So department name does not rely on employee ID. Department name is indirectly tied to the primary key through department ID, and that is the transitive dependency that we have here. Okay, so third normal form. So here we have some books from the library. I just chose some books from the library. We have the Harry Potter series to save room, and so I could put everything on the PowerPoint. I just called it the Harry series. We have IQ, Wool, great book. If you haven't read it, highly recommend it. A Child Called It, probably one of the most heartbreaking books I've ever read. Under and Alone, great nonfiction book. Now, the genre is dependent upon the book title. So I know Harry Potter is fantasy. I know IQ is nonfiction. Wool, I know, is fiction. A Child Called It, Under and Alone, I know those are nonfiction. So the book title, all of these are determined by the book ID, and the book ID is our primary key. Now, the transitive dependency is that by knowing the book title, we can know the genre without having to know the book ID. The genre relies more heavily on book title than book ID, which means we need to go ahead and separate this table into separate tables. Now, you do not create a separate table for checked out. So checked out creates what's called a one-to-one relationship. So here I have fiction, nonfiction. We could also throw in fantasy because the Harry Potter series is fantasy, more closely related to fantasy than fiction. But checked out creates what's called a one-to-one relationship. If checked out is 2, that is tied to false. If it's 1, it is true. That means for each this creates a one-to-one relationship. we don't need two different values. It's either going to be true or false. Now you may be saying, what about the genre ID? We could have multiple genres, and if we update the genre IDs, that'll update all of these genre IDs. For example, let's say Harry Potter and Wool, they get reclassified as fantasy. Well, then what we could do is change fiction to fantasy. Now we only need to change this one time rather than finding all the fantasy ones that are currently fiction and change them to fantasy. Checked out, you don't need a separate table for that. It's either checked out or it's not. It creates a one-to-one relationship, and when you have a one-to-one relationship, you don't need it. You can get rid of it. It's either checked out or it's not. We can write one of those two values there. This is what it would look like in third normal form. We have the book title tied to the book ID. We have genre ID, which is a foreign key because it relates to the primary key, genre ID. We also have checked out. This is what it would look like in third normal form. Now, if we had the author here, we would also need a separate table for the author and then use a foreign key to tie the author to this table. But this is what it would look like in third normal form. If you have any questions, please post a comment below. We'll see you guys in the next video.